Let's talk some computational design. You will notice now that I'm trying something new. I'm experimenting with something. I usually make these structured videos, semi-scripted, where I try to be very concise and give you some overview over some particular subject or teach you how to program and so on. But I thought I'll start doing this more podcast, let's say, style videos, a bit more long-term, where I don't structure anything, don't script. And to see how it works, so that it will be a different feeling. I will give you some opinions off the top of my head on different subjects, and you will get to know some things that are maybe more interesting for you about different topics. We'll start with computational design in general, but we can talk about different projects and so on, different software, and we'll see how it develops if you like this format. So I thought I'd start first by structuring this video about the idea of computational design, what I've been doing for the last 20 years, and give you some overview and maybe some advice, some lessons, talk about some mistakes that I made, talk about what you should think about if you're entering this area or if you're experiencing this area. So I will start by giving you a little bit of history, because many of you or most of you don't know any of it, and some of you might even be watching this channel for the first time. So I am originally an architect, studied architecture in Serbia, finished in Serbia, and then went to do my PhD in Stuttgart University. That was a big jump in my career. I was very lucky to land there, because Stuttgart has a very rich history in freeform architecture, lightweight structures, starting with Frei Otto, and then has this incredible series of engineers from Jörg Schleich, Werner Zobeck, my professor, Jan Knippers. And we have, of course, some of the names known in the computational design, like Achim Menges, who became a professor when I was there doing my PhD. We were in the same building. Our two institutes, mine was ITKE, and his Achim Menges' institute is ICD, Institute for Computational Design. We did all those, the two institutes did all those pavilions together that are relatively famous and so on. But the history is that when I came to do my PhD, I started immediately working for the office of my professor, the Knippers-Helbig engineering office. And there I started working on projects like Maitzeil Fuchsas, designed by Fuchsas, White City in London, another free-form grid structure, and Expo Axis in Shanghai, where I first developed scripts to relax and create these nice, smooth grid structures. And that's where we came to the idea about my PhD, to do the statical structural optimization of these free-form grid shells. And that's where I started programming a little bit more seriously. During my studies of architecture, I didn't do any of that, basically a little bit. And when I was young, I was experimenting with it. I was programming for Commodore 64 when I was 7, 8 years old. But I always wanted to do more, never got the chance. And this was my chance, right? So now I started really, I went all in. I bought the C++ primer book and then learned C++, started making plugins for Rhino in C++. And in parallel, in the office, I was writing VB scripts for Rhino script then. And a big breakthrough for me, at least in my mind, was this project of Shenzhen Airport, designed by Fuchsas, that came to the Knippers-Helbig office. And there was no software really then, like Grasshopper maybe existed as some version, but I don't think yet. There was something called ParaCloud, or it was the beginning of this idea that we can parametrically design stuff. And then I thought, okay, I'll write this script from scratch that generates the entire facade and the entire structure for this largest freeform surface, freeform object in the world at that moment. And to my surprise, and maybe to everyone's surprise, I managed to do that, and I did it alone, right? There was a huge team of people working on different aspects, of course, but this parametrization and programming was done by no one else, right? Not in the Fuchsas studio, not in our studio. So that clicked in my mind. I was thinking, like, we had such a complex script, and I will talk about it maybe in some other videos, where you have to generate these hexagonal panels, 3D hexagonal panels over a double curved surface, always keeping the glass flat and so on. And I thought, a single person generated a script that you can press a button and regenerate the entire facade and the entire structure for the largest freeform object in the world. okay, this might be the future, this is what I want to do. So this is like my summed up history of how I then finished my PhD in 2011 and decided to make my own company that does this, right? I called it Programming Architecture. This is not the official name. The official name of my company is Once More GmbH. It's changed a couple of times throughout the history for different reasons, but it's known, I think, online as Programming Architecture. And there is a lot of experience I gathered along the way that I can share with you and that can maybe help you or not. So I don't want to make this a 2-hour video. I could easily, but I'm going to talk a little bit about a couple of aspects that I find important. And the first aspect that I find important is once you do want to do computational design, do you find a job at some office, or do you try to become self-employed and have your own company? And from my experience, these are two completely different worlds, right? So you have to think about that. When you work for a company, let's say you apply for a job as a computational designer, or just a caveat here, I don't like the term computational designer, and I will tell you about it in a second, because it implies that most computation that we do as computational designers is in the design phase. And from my experience, I almost did nothing in the design phase, but I will talk about it a bit later. So let's say like a developer, you're a programmer in the world of architecture and the building industry. You find a work in an architectural office, let's say Foster & Partners, Zaha did Architects, Bjarke Ingels, these large offices that have very complex objects. Most of your work is actually your work, right? So that's most of your concern, how to do your work. If you find your own company, most of your concerns are about how to find work. So as an employee, you don't have to think about it. That part of the work is done by others, and it's just presented to you, and you have to do your best. When you're self-employed, that's the biggest hurdle you have to pass, right? How to actually find work. And there is a lot of what I can say about that. I will touch on that in a couple of different subjects that we talk about. But that's the most complicated part, and that's why there is a huge difference. Part of the difference is that if you work in a large office, most of the time you don't get enough credit, let's say. If you work for Bjarke Ingels gets all the credit, right? If you work for Foster & Partners, Norman Foster gets all the credit, right? Rarely someone speaks about some breakthrough in parametric design that maybe brought the design to fruition. But if you have your own company, there is a big difference there in what type of objects and what type of computational design you do if you want some credit, and I'll talk about it in a second. So let's continue down this road and say you want to make your own company. My first advice is to find a partner. And there is this cliche story about Steve Jobs, right, and Steve Wozniak that I think is really important, however cliche it is, because you always need this nerdy type, the technical type that can actually produce stuff, and you need a marketer. And from the beginning, I myself tried to be both, but I am much closer to Wozniak, let's say, someone that's introverted, interested in algorithms development, try to actually do the technical stuff. And because of this introversion, I was never able to call and network and so on. And that I suffered a lot in that sense. I think I could have gotten much more work. But that's my advice, right? If you're that type, find the partner. And having a partner is generally good. I mean, I always quote this book. It's a very interesting book about the HOK, the famous large architectural office that's on the market for 100 years. And there is a reason why they're there for 100 years or more. And that's precisely because they divided these kind of roles from the beginning. There were 3 partners. One was concerned with the design, one with technical aspects, and one of them solely on networking and finding clients. Because every lunch, every dinner he does, it might result in some project in 5 to 7 years. So if you're on your own, that's something you have to think about, because you have to constantly work on that. Even when you have a lot of work, you have to think about the next project, about something that will come 2 to 3 years from now. Now, there's different types of computational designers, right? So I mentioned architects in architectural offices, but there are computational designers in big offices that do fabrication, facades, general contractors, and so on. And if you can decide from the beginning, sometimes you can't. It just flows, and you get thrown to wherever you go. But it's completely different to be a computational design in an architectural office or working in these first stages of design than afterwards, in the construction planning, technical details, shop drawings, CNC files, and so on. I was running away from the design since my studies because I found it too subjective. I found it too random. I found that whoever succeeds in that part is not doing that based on some objective reasons, but some very random and lucky reasons. Right? Yeah, I still think that the successful architects are not successful because they're best designers, but because they're best managers. They managed to build what they design, right? So that's why in the last 20 years almost, I rarely work with architects, almost zero. Almost all my work was came after the design, right? How to take that simple wireframe at the beginning and then create complex 3D elements, all the details until the 0.1 millimeter, how to create CNC files for production, how to create automatic assembly plans, and so on. Everything after the design, how to basically transform that design into the build structure. And there is a huge difference in those two. First of all, there is much more value to be generated in this other part, where I am. And since there is much more value, there is also a lot more money if you know how to generate it. And there is much more understanding about what can be automated. I feel that architects are still a little bit conservative, aside from aforementioned some big offices. They, of course, know what computational design is, and they have internal computational design teams and so on. But generally, there is a little bit of understanding, like how can the design help you and how it can accelerate you. And from my experience, these big architectural offices have maybe some interns or some young people do some crazy computational design here, and they see them move some sliders left and right and change the shape of a skyscraper. But they think that's it, like we're playing around a little bit in the design phase. And because they don't have contact with the later phases, they usually give the design over to someone else. And then I work, and my company works for that's someone else to create all the production files, right? And I keep preaching this, like, don't do that. We should create this system where from the beginning, these sliders that you're moving around when you're designing, those sliders and the code behind can then be expanded and expanded and expanded. That will get full digital twins. And then when you're done with the project, you just click a button and you have all the shop drawings or the CNC files, everything ready for production. But we have this split of responsibilities, and that's where the problems comes. And then in this design phase, there is not a lot to do. There is an upside to that, though, and the upside is that when you work as a computational design in that phase, you get to show a lot. And when you get to show a lot, you kind of get some kind of a credit. So if I open my LinkedIn or my Instagram and we follow each other with the computational designers, we know what we do, I see some of them posting almost every day, right? And then get large followers and so on. And if you look at who those people are or what they do, it's usually something in the visualization part, this design part. So they're moving some sliders, they're showing some AI generated images and so on. And so that's great if you want to show something. And if you want to share or teach and grow your popularity in that sense, because if you work in that stage, you get to do that. Of course, if you're inside some office like Bjarke Ingels or Zaha Hadid or something, you won't be able to do that. But if we're talking about an option, if you are like a computational designer and work on your own, and you get to fight for producing your own kind of content, then you get to show a lot, right? If you work in the areas where I work, there is really nothing to show, right? When I come in, the design is done. We then start generating automatically all these complex details, and there we work for fabricators, facade planners, general contractors, and they don't want to show any of those details, right? There's a lot of secrecy there, a lot of IP involved, a lot of intellectual property. From my point of view, way too much. I don't think that kind of secrecy is needed, because 99% of those details and stuff that are developed are kind of known or logical. You can even go to the done building and you can see those details. I don't think there is anything special there. But you can't tell that to those companies. I mean, they all hide what they do and how they do, or try to anyway. So in all those contracts, they forbid you to show anything. So in my history, since I made my own company in 2011, I worked on a lot of different projects designed by Zaha Hadid, Moshe Safdie. We had like couple of Foster and Partners projects. The last one is the Las Vegas Sphere, the Share Zedek Medical Center. Before that, the Kuwait International Airport, the Kapsark Research Center by Zaha Hadid. There are a couple of big and very interesting projects, but whenever I tried to kind of talk about it, what we did, how we did it, I couldn't, right? For one project with Kuwait International Airport, we generated all this reinforcement for the entire concrete slab, concrete panels of the airport. I can't show anything. For the Las Vegas Sphere, it was the culmination of all our experience when we generated from the simple wireframe the entire structural model, the FM model, statical model, all the details until the very screws and bolts. We had 30,000 unique aluminum profiles, 6 meters each on average. Each one looked like a Swiss cheese. Each one had on average 150 to 200 works on them. So holes, drills, pockets, and all different, right? And so you, at the click of a button, you generate those in 3D. You generate them as G-code, a CSV file that goes directly into the machine, no human intervention. Then assembly, and you all do that all with a couple of people. And then you think, we can make like a Netflix mini-series out of this, of how this is done and what we do and what innovations did we bring. And then you realize you can't show anything, right? I can show you, yes, we worked on the Las Vegas Sphere and that's it. And if we work together, then you can see how like our methods of what we can do or how we can do. But the advice that I'm trying to give you, that is, if you can decide to go more into the design phase as a computational designer or more into the fabrication phase, those are the trade-offs. In the design phase, you get to show a lot if that's important for you. In the fabrication phase, you get to solve much more complicated problems with much higher responsibility, right? Like, you can't make a mistake there. We had a lot of aluminum profiles that we have to redo because of 0.1 millimeter mistakes between the holes, and so. And if you make a mistake, there's huge cost because the fabrication goes wrong, and so a lot of responsibility. No credit, but of course you can probably earn more if you negotiate well. The design phase, you play a lot, it's fun, you post on LinkedIn, you post on Instagram, you get tens of thousands of followers, but the puzzles you're solving are not that great, and they're not so satisfying in the sense, because because the stakes are not so high. If you make a mistake, it's not a big of a problem, and in the fabrication, you get to see actual details of how everything comes together. Now we can expand on this. Of course, there is good sides, bad sides on both, but that's a kind of good distinction to think about. Luckily for me, in the last 2 years, I restarted doing finally something with architects. I found a really good architectural office here from Austria and Germany, and they are forward-looking. We're using AI, we're using Rhino inside Revit. We're creating our own system to parametrically generate normal, simple, mass timber buildings. They realized how much you can automate even with those buildings. And but that's rare. Like, if you get to find that, that's amazing, and that's kind of your ideal when you try to cover the whole thing. And that's ideal also because, for me, because I finally get to prove this thing, that you should start with the design And with those sliders and changing the shapes and changing the position of columns, you grow your code and your system, and you create this digital model. You start creating, automating the connections between beams and columns and the facade and the brackets of the facade and so on. And it grows and grows and grows. And you have this fully parametric digital twin that then you just export at the click of a button. CNC files, shop drawings, assembly files, so on, plans, and then everything can be streamlined. And that goes back to that famous McLeamy curve and so on, but can't talk about everything now, right? We're not going to do this for 8 hours. My plan is to try this out. This is my first video that's of this type, let's say podcast type, except there's no interviewer. But if you like it, and if this is something that gains traction, there's much more branches we can cover. Now, architecture fabrication is one division. Small projects, big projects is a very important division. Also something you can't really choose. But if you look at on the internet, and you check out the computational design stuff, there's a lot of interior design, right? A lot of furniture, a lot of pavilions, a lot of small stuff. You don't see that much big stuff. Why? Well, it's not that it's not used, but it's not shared, right? This goes back to what I talked about. Only if like the project is done and then officially like Zaha Hadid Studio or someone will create some video or something about how it's done, that's usually the process. And it comes later, So this type of projects are very big, they last very long. That's also something you need to consider. You work on an airport that likes 5-6 years and then it gets built, and then maybe if you're working on something now, you can show what you did in 7 years from now. So you have to consider that. Other thing is that this is the road I've taken to work on large-scale projects, and there are many problems there. First of all, like we have like a couple of people, and then we try to plug in and work together with, I don't know, Arup or someone that has 100,000 employees. So first problem is, how do you get work? How do you get in there? You get work by being better than the computational design team, or being lucky that they don't have time. This second happens rarely. It happens that they just don't have time, overwhelmed, so they have to outsource. But most of the time, all these big companies have now computational design teams, and they will go and ask, can we do this? And if they say, no, we don't know how to do this, or we can't do it as fast, then I will try to jump in and say, yes, we can do this, right? So what will happen then? Then we get to work on the project, and of course, every company will try to do that in-house for the next project. They will try to get their employees to learn how I did what I did, not only me, my team, how we did what we did, so that they can keep it in-house, right? So every time you have to stay at the top of the game. You have to stay cutting edges. You have to say, oh, well, we did that, but now we can do this. Now we can introduce AI. Now we can automate CNC files as well. Now it can go faster. Now we can go create G code from scratch, and it can go to this machine as well. And so you always have to up the game. And if you're not up to that, if you want to have a relaxed job where you come in and have coffee and don't rush, that's difficult. That's one of the aspects on working on large projects, because it's a very, very weird situation, right? You get to be like this geek team of a couple of people that's trying to do something that's huge and works with larger teams in other companies and have to coordinate all that. And they all try to kind of kick you out. They all try to neglect you. They all try to, not intentionally, like these are all good people, right? But in the back of their mind, they're asking themselves, why are we doing this in-house? Or how can we do it next time? But that comes to finding right partners, and this is maybe the point that I skipped, and it's very important, that if you want to be on your own, you have to find these large partners from the beginning, where the work is going to come from. You have to find these large companies, if you're working on large projects, of course, that will have trust in you and that will give you work, and slowly in time, maybe they'll give you work even if someone in their team can't do it, because they wanted to push away the responsibility. Because you cannot forget that, right? You have a lot of responsibility. Imagine if we generated CNC files for the Las Vegas Sphere for 30,000 aluminum profiles and so on. And imagine if the files went directly to the CNC machine. We had a lot of automated system of error checking, but maybe we could have screwed up something, and there would be millions and millions and millions of costs in damages. So sometimes you will get work, I'll add that to that list, not only if they don't have time or if they don't know how to do it, sometimes because they want to shift the responsibility. But then you have to be also careful because the responsibility is also part of that decision, if you want to work in the design or afterwards. I'm jumping back and forth from theme to theme. That's I guess the characteristic of this type of unstructured video, but I hope you can follow. So we jumped back to your decision if you want to work in the design or fabrication. The fabrication, the responsibility is much higher, right? In the design, you can move those sliders, have some shapes, generate them, and that's easy. And then you export those shapes, and those shapes then come to me. And then I take them as an input to try to generate everything else. But you're not really that responsible for those shapes. And that comes from this division of work in large offices. If you work on some smaller things like pavilions or something, that's done usually everything in the one office, so it's much easier to do. And because of this division, it's interesting maybe to know, I don't really have contact with architects. Right? So recently I had like an online lecture at Foster & Partners, and it was funny because we kind of knew each other there. People know me from my content and so on, and they were telling me, yes, I was dealing with your files. I was opening your files and so on, but I'd never send them to them directly, right? It all went over the general contractors and fabricators. So I worked with them, and then they communicated with the architects. So my files ended up here. And it was funny to see, and I mean, it was really a nice talk. But I never met Norman Foster. I never met Fuchsas or any of the famous architects, because everything is detached and discontinued if you work on these large scale projects. Sorry, my video just cut off there. So I have to go back to my chain of thought. I was talking about architects basically dividing the responsibility. And I will use this opportunity that the video cut off to stop here and just remind you to sum up what we talked about. And then I can, if you like this type of content, I can kind of branch out and go into the future in all these different directions and explain to you. But the point was that my history was that I was an architect. I didn't know anything about programming. I learned how to program during my PhD, and you went into this computational design like you can by teaching yourself how to program, how to code. The first big decision is if you want to work for a big office, because smaller kind of don't really need computational designers yet, or to try to make it on your own. Those are two completely different worlds, and I'm pretty sure in the future we'll talk about more about that, because I basically got to scratch the surface of that topic, and there's huge differences. If you do go to make your own company, you have to find a partner. You don't have to. I try to do everything on my own. I'm still trying to do everything, but if you can find 1, 2, 3 partners and divide the responsibilities, that's amazing, especially if one of them only solely does marketing and does client searching and networking, because you have to do that constantly. Even if you're full of work, you have to do that, because you have to think 2, 3, 4 years ahead. You have to decide if you're going to go more in the architecture or fabrication directions, because if you can, and that's coupled together with going into the small scale or large scale projects. So those two things kind of mix together into sort of a table. If you go more into the architecture and design direction, the responsibility is smaller, because the risks are not that big, the stakes are not that big. You can't really make mistakes in the design that are not visible and that you can see after you produce millions of worth of elements, right? And you can also show more. If it's important for you to share, to show what's important for me, and that's one of the reasons why I'm gravitating much more back toward the architecture, because I can't really show anything on those from those projects that we worked on. I will try to talk about it, to talk to you without showing the details. I sometimes try to recreate stuff by programming similar stuff and so on, but that takes a lot of time that I don't have. So I'm gravitating more toward design and architecture because I try to cover this whole chain, and that should be the ideal for you as well. We as computational designers or developers, we have to prove that if you start making this code from the beginning, this system, from these slider moving, you can create full digital twins and get them ready for production. Again, coming back to the McLeamy curve, which we can discuss some other time, but you can do that relatively easily if you work on small scale projects, because they're done in one office usually, like interior stuff that we talked about, or smaller pavilions or smaller houses. But it's still a huge challenge to do on large projects, because it's so discontinued, right? And then you become invisible there in that whole system, and there's no credit, there's nothing you can show. But the trade-off is that you have this huge satisfaction working on something that's very high stakes and very high, you solving very complex problems, and then you see these objects like the airports and the Las Vegas Fair, and you know that you had a part of it and you generated all those elements and so on. So there is a kind of a larger satisfaction, and that's a debatable, of course, depending on the person you are. Maybe someone has larger satisfaction in doing some design stuff. But that's all that we're going to talk about soon. The important thing is that you should let me know if you like this kind of contact, so that I know if I should continue a little bit more in this direction as well. You will let me know by subscribing, by commenting, by following on LinkedIn, following here, and most importantly, go to gasworld.com. There you will register, and you will find 10 plus hours of free Rhino developer C# course. I used to sell those, but now I made them completely free there. And the reason is that I'm not in this content creation game to sell stuff, right? A lot of people sell courses and so on. So even when I did sell those courses, I did not advertise them. Zero. I mentioned them on my videos, but I never tried to actively advertise them, because that's not my goal. My goal, I offer services, right? I want to work on these large projects and develop stuff and develop software and offer services working on these projects. That's my goal. I don't want to sell anything aside from my work. Even the software that I'm developing right now, called Gas, you will be able to get it for free once I upload it to gasworld.com. I don't know how that will develop. I developed a lot of Rhino plugins in the future. Then I discontinued them because I didn't have time. But I'm just putting back all those algorithms back into the Gas software, and it's pretty complicated, but I think pretty cool. So it will be interesting for you to go register and have access to the free version once I'm ready to publish it. But that's all that can be said for now. Please subscribe, follow, and let me know if you like this type of content, and I'll talk to you soon. Stay free.